Yes, you have read that right. The title of this section is Proofs of Properties of Logs. I don't want to scare you with the proof part of it, but what I want you to realize is we're going to be looking at different log expressions and some equations. And there are going to be different things we're going to be able to do to either solve them or simplify them, or maybe just evaluate and simplify things down. But the reason it's called proofs of properties of logs is just like when you did geometry proofs, you knew where you started, you knew where you had to end, but how you got there was different types of processes. So there's not just going to be one distinct process to get you to the end, and we're going to be looking at using properties of logs. And I'm going to teach you a couple of shortcuts in this process. I'll show you why they work, and after I show you why it works, we'll then use them. Just like, again, you did in geometry, there were some nice theorems that shortcutted things. Once we proved them, then we were able to use them. So, to start, here's just a basic log property, log base 4 of 563 to the x. So, if we go through and try to figure out what this is, I cannot do logs of base other than 10 in my calculator, so I have to rewrite this. This is in logarithmic form, so the very first step would be to rewrite it into exponential form. So I have my base, a logarithm equals an exponent, so to my exponent equals my argument. So now 4 to what power gives me 563? You probably realize that that's not going to be a nice integer value for x, because 4 times itself a certain number of times cannot end in a 3, 563. So because of that, I now have to get that exponent down. Now it might look weird because we already had a log in the previous problem, then I moved it to exponential, and now we're going to get it back into a log form. But we're going to do this so we can come up with what our exponent is. So what we're going to do is we're going to log both sides, just like we did in the previous lesson, because once I have a log with an exponent, that exponent comes down in front. So now this is x times the log of 4 equals the log of 563. So I have to get x by itself. So what's attached to x? Log of 4. The whole thing is attached by multiplication. So we have to undo multiplication by division. So divide both sides by log of 4. So now on the left-hand side, I get x equals, and on the right-hand side, I get this whole quantity. Now, I could type this into my calculator, get my answer. Please note, if you did that, when you type the log, a parenthesis opens up. Make sure you close that parenthesis as well. Otherwise, it's going to divide it by that log on the bottom. It's going to do order of operations. Oops, incorrectly. So just be careful. Okay. Now, I'm stopping at this point because I want you to see something. We started with the very top, which was, I'm just going to rewrite it in the opposite order, log base 4 of 563. So if you notice, the black is where I ended, the red is where I actually started. Do you see any commonalities between the two? This is a really wonderful property, which we call change of base. If it is in log form, I can take the log of my argument and divide it by the log of my base. And that gives me my x value. So this is shortcut number 1. This is showing you how it works with a specific case. So shortcut number 1 is called change of base. This one actually has a name because we use it so often. The other shortcuts we do aren't going to have names. So change of base says the log of any base of x equals the log of your argument, which is the x, over the log of your base, which is your b. So I can instantly go to that process, type that in my calculator, and get my answer. Okay, good. So using the change of base property, I want you to evaluate these 3 logs. Do change of base. Log of your argument divided by the log of your base. Again, make sure you close up the parenthesis. Take a moment, pause it, and do A first to make sure that you can get it. And then I'll have you do B and C. So for A, I'd be doing the log of 28 divided by the log of 7. When you type that into your calculator, 3 decimal places out is 1.712. Okay, so just making sure that you can do that right. So now please do B and C on your own. So log base 5 of 78,125 equals 7. So in other words, I could have factor treed 78,125 and broken that down. And I would have gotten an integer value because 5 to some exponent, 5 to the 7th, equals 78,125. So I'd have a 5 and then keep going. This is 5 to the 7th. Okay, then the last one. You type that in your calculator, it gives you an error. Tells you doesn't work. But why? What I'm trying to do is I'm trying to evaluate it. I'm trying to find what the number is. So I'm trying to figure out what does this quantity equal. I'm just putting a variable in there because that's what I'm trying to actually find, what the physical problem simplifies down to. So if I were to rewrite this problem exponentially, my base to my exponent equals my argument. So 4 to what power gives you negative 22.4? Nothing. It is not possible to have a positive base and get a negative answer out. That is why we have no solution here. So be careful of those negativities, because again, since that base was positive, I can't take a positive number and multiply it by itself a bunch of times and get a negative number out. Okay, so that's using your change of base process. Next one. Here's a change of base as well. However, what I have to look at too, I have an exponent attached to a log. What do I do with exponents and logs? We yell at them to get down in front. So this is 8 times the log base 49 of 49. So now I have that multiplication in front, and I have a log, so I can separate my log out. Log of my argument over the log of your base. And that, of course, is multiplied by that 8 in front. Log of an argument of 49 and the log of a base, which was 49, is 1. And 1 times 8 is 8. A wonderful shortcut that takes place. Wonderful shortcut that takes place. Now, keep in mind, part of the reason this works as well is I could rewrite this into exponential form. I want you to see what this looks like. Log base 49 of 49 to the 8th. We're trying to figure out what it equals. I'll just set it equal to something. So I can rewrite this exponentially. So when I rewrite this exponentially, my base to my logarithm, which is my exponent, equals my argument. W therefore equals 8. Another way to go about it, using just switching forms from log form to exponential form. So both of these ways work out, and both of them, the answer is just the exponent. So here is shortcut number 2. Shortcut number 2, again, doesn't have a name, but if you have log base x of x to the y, if your base and your argument are exactly the same, your answer is just the exponent every time. Next example. Okay, this one's a little bit messy. However, when you actually look at it, it's not quite so bad. There is an exponent, that negative 2/3 is an exponent, and then there's a multiplier. So, and then I have a log with a base and an argument that's the same. So one of two things. Either take the 3, move it up top, because exponents, or numbers that are multiplied by a log, can go up into be exponents, so be power to a power. Or take your exponent and move it down in front. Either way you want to do it to simplify is absolutely fine. If I move it in front, it's going to be multiplied. If I move the 3 up top, it's going to be multiplied. So either way, I'm multiplying 3 times negative 2/3. So the 3's cancel. I'm left with negative 2. So this is negative 2 times the log base 24 of 24. And as we talked about, when the base and the argument are the same, the answer is that multiplier. That multiplier sometimes might be 1, but that one's a negative 2. Another shortcut property that we're going to see is 3 to the log base 3 of 7. So you should again see a little bit of similarities taking place. I want to evaluate this. I want to find out what this simplifies down to. So I'm going to say this equals j. And I want to figure out what it equals. That's what I'm trying to figure out. That's why I'm evaluating it. Right now, it's important to know that this is an exponential form. Reason being, there's a base, and this is the exponent, which is why it's an exponential form. Yes, the exponent has a log, but it is an exponential form. So I'm going to get it out of exponential form, and I'm going to write it in logarithmic form. That's why it's so important that you can write both directions very easily. So this is log, my base is 3, of my argument j equals my exponent, log base 3 of 7. Because remember, log equals an exponent. So when I write it into logarithmic form, it equals the exponent. Hey, compare them. They're equal. Same base. What does j equal? 7. Because the base of my exponential and the base of its exponent, which is a log, are the same, my answer is the argument. This is shortcut number 3. So x to the log base x of y just equals that argument y. And there's one more, and I'm just going to do it right on this shortcut page. This one will come up across the board too. Multiplying multiple logs. Log base a of b times log base b of c times log base c of d. This simplifies into a single log. So think about it for a moment. Before you continue to hit play, look at how might you rewrite this? What could you possibly do to it? I will tell you right now, you cannot change it into exponential form because there are multiple logarithms, okay, being attached by multiplication. It'd have to be a single logarithm if I was going to write it into exponential form. So take a moment, think about, look at what we did so far today. See if you can come up with a way to simplify this. So I'm going to go through and I'm going to do change base. Log of your argument over the log of your base times, because it's a multiplication, log of your argument over the log of your base times the log of your argument over the log of your base. Multiplication. Is there anything in the top and the bottoms of these fractions that directly simplify? Yeah? Log b? Log c? What's left? Log of d is on top over log of a is on the bottom. Now reverse change a base. Got to go both ways with these. This is log, what's my base? Denominator is the base part, and your argument is the exponent's argument. So this simplifies into log base a of d. That whole math simplifies into a single logarithm with a single argument. So sometimes only one of them might cancel out, maybe a bunch of them, depends upon how many you have. But if you rewrite them, you can start to see some nice things that take place. Problem number 4 here is really a proof type of problem. Based on what you know about properties, you can break down your logs, rewrite them in different forms, and out pops simplified expressions. Now, some of your homework problems, you are going to get some really tough problems that you're going to have to be able to break down. Please know that some of them are incredibly hard, and it takes one little thing, and they become really easy. So keep in mind that you need to be doing those problems first before you try to look at the answers. Because if you remember back to geometry, when you were going through and you were trying to prove something, you were trying to simplify the process down, it made sense usually when the teacher went through it, or your friend explained it, or you looked at the answer in the back of the book. But would you be able to replicate a different scenario using some of the similar processes without someone telling you explicitly what to do? So keep that in mind when you're doing these. You have a whole bunch of log properties, well, 3 specifically. We've given you some shortcuts that work here, and then don't forget you can always change something from log form to exponential form or exponential form to log form.